Hi all, it's Brendan, and today I'm going to be doing 30 Days of Solidity Day 11. And this is where I'll be creating a master key smart contract. Right? This is essentially an illustration of creating an ownable interface, or I should say ownable implementation, and inheriting that inside of here, right? So master key is ownable, and I've also got an empty ownable contract here. So that's essentially what we'll do. So firstly, we need to import the ownable smart contract, right? In this case, not an interface, but an implementation, ownable, right? And that should do it, right? So now we have master key is ownable. Before we implement master key, let's actually implement ownable now that they're linked together. So let's see. So this is going to be pretty similar to IOU, which already had like some simple IOU which had an ownable implementation. So we had manager, and then the constructor would set the manager, and then it would only have an only manager option, right? So I'm going to copy all of that and modify it accordingly. Right? Instead of calling it a manager, I just call it an owner. Right? So let's get rid of all of that and that, right? So only manager is allowed to perform this action. Now, one of the other things that the ownable interface I'd like for it to do is to be able to transfer ownership, right? So for that, we'll have a transfer owner function. Okay, so it's critical that the transfer owner uses the only manager modifier. Actually, that's a good point. Only owner, I should call it only owner. And rename all of this. Right. So transfer ownership uses the only owner modifier so that ownership can only be transferred by the current owner to the next owner. Right? And so we'll pass in a parameter of new owner, and we'll do a bit of validation before we move it over. Acquire new owner not equals to owner as well. We don't want that. And then owner is equal to new owner. And then let's add some error messages. So this is essentially rejecting the transaction and reverting it if it is a null operation, because then the result before and after will be the same. So that's redundant. And let's also emit an event. Right? So emit owner update, owner new owner. So this is the current owner because it hasn't been overwritten yet, and then there's a new owner. And let's define the event as well. So event owner update, and that will have both previous owner and new owner. Address previous owner and address new owner. And another thing I'll do is I'll also make this indexed so that it's searchable, or I should say filterable by this. And so we have a basic ownable implementation over here. And so now when we go back to master key, it's already imported ownable, and it says master key is ownable. And that means that the master key contract will have this, it'll have access to everything that's inside here, right? It'll have access to the constructor, which we should call in the constructor of master key. It'll also have the only owner modifier and the transfer owner function. It'll also have the owner update event, and it'll also have access to the owner variable. So all of that is inherited, and essentially we can use this in our implementation. So constructor ownable, and I think we don't need to do anything inside of the constructor. We just need to call ownable. In fact, we could just delete the whole thing and it implicitly happen anyway, but I prefer for it to be explicit. All right, so then let's, and so what does a vault will do is basically saying anyone can put money into it, can transfer cryptocurrency into it, and then only the owner can withdraw the value, which is the balance of the smart contract. So function get balance, public, it should be view, returns uint 256 in parentheses. And the implementation will be pretty straightforward, just return address of the current smart contract, and then balance, dot balance. All right, deposit will be the next function. So function deposit, public playable, and all we want to do actually is just emit a vault activity method, event I should say, message.sender, and then let's also introduce an enum, vault action dot deposit, and then the amount, message.value. So let's define these two. Right. So we'll have an event, vault activity, and we will also have an enum for vault action. Right, so vault action can be, let's just go with deposit and withdraw as two possible options, and then for vault activity we want address, vault action, and uint 256. We'll go with address account, vault action, and uint 256 amount. All right, and let's go with indexing on address. So it's filterable or searchable by that. Maybe we could even do vault action index as well, right? Maybe not. All right. Okay, so we've got an emission of that. Now, one of the other things that I would like to do is also create an alias, right, for a built-in function. So we don't actually need to use it called, you don't actually need to use a function keyword, right? It's kind of saying if the smart contract just receives a transfer, then automatically call this method instead, right? So I'll go receive, right, which is the special keyword, external table, right? So this basically will get triggered when the smart contract gets a transfer without actually specifying any method name. So it's not calling the deposit function, it's just saying trigger this, and then it'll just basically relay this to deposit, right? So the deposit function gets called when a transfer is received from any account. All right, so that should do it, and then let's move on to withdraw, right? So the difference between deposit and withdraw is that anyone can withdraw. So function withdraw, anyone can deposit, but not everyone can withdraw. So withdraw, so this will be public and only owner, right? Public only owner, and then I'll say require something. I'm not sure what I'll require yet. Maybe I'll specify, yes, the owner should be able to withdraw to any other account, right? So the owner doesn't necessarily withdraw to their own account. Let's make it that way. So address recipients, I'll make it address payable recipient. Right, and then also specify the amount, UN256 amount, right? So I'll require that recipient is not equals to the null address. So and I'll also require that the amount must be more than 0, and amount must be less than or equals to get balance, right? Which is basically the current smart contracts. All right, so then the next thing is to actually do the transfer. So recipient dot call value amount, and the call data will be empty, and I'll need to do bool transfer success, and then we don't care about the second parameter, assign that, and then we'll do another require, so require transfer success to be true. Transfer failed. Okay, so I've got require transfer success fail, and I think that should do it, right? Oh, actually, I will want to emit a vault activity. So emit vault activity message.sender vault action.withdraw for now, and then message.value. What's it complaining about? Sorry, not message.value, it should be amount. Right. Okay, so that's my withdraw function. Okay, let's deploy the smart contract now. So compile, and then I'll deploy All right, so we've got a master key. All right, let's deposit 1,000. Deposit. And then if I call get balance, I get 1,000. Let's say I deposit from a different account who is not the owner. Right, I deposit 2,000, right? And then I press deposit. And so now the balance should be 3,000. And if I look up the owner, it's 5B3. And currently I am, on account AB8. So if I try to withdraw to, say, myself, this current account, so I try to do this, recipient is this, and I try to withdraw 100 and press transact, it'll reject because it says only owner is allowed to perform this action. Now, if I switch back to the owner account and I press withdraw again with the exact same thing, so I'm not withdrawing to the owner account, I'm withdrawing to the other account and press transact, it'll succeed, right? And importantly, if I look at this, right, I will see that there was a transaction log for Vault activity, right? So 0 corresponds to the Vault action.deposit, and 1 corresponds to Vault action.withdraw, and 2 is the amount. The first parameter is the address, right? So this is the event log that that indicates Vault activity. All right, so we've got we've demonstrated that we can use Ownable, right, implementation and share that across multiple implementations. So now if I want to implement another smart contract that is also ownable, right, I do not need to re-implement ownable. I only need to do the specific logic for that other smart contract, just as how I've done it with this one. All right, that is all. Thank you very much for listening.